I know it's week 4, but we're doing week 3 because we're behind. Now, pray. And where's better? So, if you don't know what to do and you just log in, say CD with nothing, that takes you home. Then you make your directory for today, which is 2011-1206. Then you change into that directory, 2011-1206. If you're not sure where you are, you can type PWD and you can see, yes, I'm in the right place. Now, I said the first thing to do is create hello.c. Hello.c. It's pretty simple. Okay, so that's hello.c. The next one to make is emitter.h. One line file, very simple. And then make emitter.c. Inside today. After you finish, you should have the 3 files, LOC, emitter H, and emitter C. Since you practice 30 minutes every day, except for yesterday, that means you had 3 hours of VI and Mercurial. You should do pretty good by now. Now, let's go back to the first page. The first page says week 3. Okay, we're going to try these techniques. We're working on separate compilation with object files. So, we need to compile the emitter module. Something like this. Okay, there's your compile, no warnings, he liked it. The next one to compile is almost the same, but we need to do hello.c. Okay, now we've compiled the object files. The last thing we have to do is link it all together into an application. So when we want to do that, we can do something like this. Okay, then we run it. Easy. Okay? Pretty step by step, pretty forward, pretty easy. Some things you may not know about this. If the line is too long, if it's too long, then you can use this backslash to say continue on the next line. But there's a special rule. After the backslash, you must press enter. You cannot have backslash space or backslash tab. This has to be backslash enter. Then you'll see this symbol which says I'm ready for more, and you type some more. Then backslash again. It says I'm still ready for more. Then you put this stuff and finally enter. So this is really one long line. If you have a nice screen like this gentleman on his laptop with high resolution, you can type one long line. But if you're on low resolution or just 80 columns, you can cut the line with these backslashes. Makes it easier to see. What we've written is, we've written a new application called Hello, and Hello is an example of separate compilation. We have an emitter module, emitter.o, and that has a special function called emit. The prototype for that function is in emitter.h, and the source for that function is in emitter.c. The prototype is used to specify what the function will return and what the arguments, what the type and order of the arguments are. You know this from C programming, I hope. If we do an ls right now, you'll see our module. Here's emitter.o module. Here's hello.o module. And then when we link these two modules together, we create our application, hello. Now what should be obvious to you is, wow, do I really have to type all of that every time? That's a lot to type for each compile. So we're going to learn about the make utility to automate the build so that it's much easier. You only have to type this really one time when you design the make file. And after that, you don't have to type so much. But I need to wait until you get the C programs typed in and built. So these are the build instructions right here. Okay, compile emitter module is here. Compile hello module is here. And then link the modules together into the hello executable is here. Be careful on your -o. -o needs to be different. Here's the source. -o is output. Don't say emitter.c on the output. You'll kill your program. Same thing here. Don't say out hello.c. You'll kill your program. And finally, on the link, don't say -o hello.c or hello.o. Okay? You have to type in the right file names. Unix is for adult people. It's not for children. Unix does whatever you tell him. And if you tell Unix, do this, he'll do it. You tell Unix, do something stupid. Unix says, okay, you're the boss. It's great for programmers and IT professionals because it's fast and it has a lot of features. But you have to be careful what you type. That's another reason to build this make file today, because the make file will prevent mistakes. I don't know about you, but I work late. 3 a.m. in the morning, I'm typing because the internet's fast at 3 a.m. Okay? I have, where is it? I have air card for the phone company for my net at my house. And in the daytime, bad connection, it's slow, it hangs up a lot. 3 a.m., really fast. So I work a lot at night. The problem is, at night I'm tired, and it's easy to type the wrong thing. So if I have a make file, together with Mercurial version control that we learned last week, I'm safe. So the next thing I should do right now is create some version control. Last week we did it. We're in a subdirectory. Everything's good. We can HG init. Remember, one time for each project. So here we go. I initialized it. How do I know it's there? The .hg. If you have the .hg, you already initialized. Now, we only want to check in source code. Source code. So, .o files, that's object code. I don't need them. And finally, what is this? This is the executable. If you're not sure, don't VI. If you VI hello, bad things happen, okay? Don't do that. What you can say is file hello. And if he says, executable, that's a program, okay? We don't want to check in the exe, executable. We don't want to check that in. Let's delete it. Now, what have I got? I've got the 3 source files. If I do hgstat, he says, you have these files, and I don't know about them. Question mark says, I don't know. We need to what? Add. So we're going to do hg, add, and then you could use star, but it's dangerous. I recommend you type each file name to be safe. So I'll do emitter C, emitter H, hello.c, hg add hello.c. Oops. So now, if I do hgstat, I have 3 files that have been added, but they're not in the system yet. When it says A, it means you did add, but you did not commit. Here's a joke in English for you. If some of you are good at English, they talk about fear of commitment. And that means that the man or woman doesn't want to just have one fan. Maybe they want to have many fans, you know, so they don't commit. But commitment is what should happen when you go steady and you have just one. So, but for our source code, it means the same thing as a database. When you commit in SQL, commit will say, you say commit work. That will make the changes really be in the database forever. The changes are in the RAM right now, but HG commit makes them permanent. So let's commit this. Remember, you have to use your user, which is S5316 something. Mine is Mr. Hale. And then I need a commit message. What's my message? Don't forget the double quotes. My message is going to be something like add initial files to project. Okay, if I do hgstat again, everything's good. The files are in the system. He knows about it. If you're nervous, you say, I'm not sure. You can always do hg log minus v, and he'll tell you, yes, you have one revision. The first one, 0. It's the tip, which means it's the latest copy. And what's in it? These 3 files are in it, in that commit. So everything's good. Life is wonderful. There's only one problem with my life. I have to type in 3 lines to compile each module, and another line to link. That's 7 lines every time I build. That's too much. I'm lazy. Yeah, I'm lazy. Look at this. Do I look like Mr. Active? No. So we have to learn some skill, and then we can be lazy. Or safe, depending on how you look at it. So the next thing we need to learn about is the makefile on page 2. But before we do that, I have to talk about some concept of the makefile. Man, I really love the chair. Yes, you will. You sure? Okay. Because these are too small. That was broken. It wasn't me. I broke one last year, but not that one. Okay, so what do we need to look at? Oh, I got a drawing program. What's the drawing program on Windows? It's not Paint. What is it?
ถ้าเราไม่ได้ทำขาย
Okay, thank you. Good. I don't know Windows very well. Okay, let's talk about trees. Let's talk about trees. A tree has a root, right? And then you have some nodes underneath it. So let's draw a tree. Our tree would depend on two nodes. Clear. Dude. So at the top, we need to put some word here. At the top, we're going to have all. You're supposed to read it, man. Okay, then all is going to depend on two things. What does all depend on? It's gonna need hello.
Hello commit.
And then we need another one. What does hello need? Hello.o. What is wrong with this? I'm never working in boxes. It's making the boxes too small. Maybe I gotta go this way. Alright.
ไม่ได้ครูก็ตามเกณฑ์
Emitter.o is gonna need.
initial file
Some line drawing people. Now we really don't have a tree. What we've got is a graph. How do I know it's a graph and not a tree? This node emitter.h has in degree 2. So it's not a tree. It's a graph. Okay? It's a directional graph, but it's still a graph because this one has in degree 2. And the rule for a tree is every node has in degree 1 except for the special root which has in degree 0. But this one has in degree 2. So this is a graph. But this is what our make file. The make file on page 2 is this picture. How do we know that? Because I'm telling you. Maybe you need more than that. Okay? So let's take a look here. Okay, can we see the picture? We can see the picture. If you said all needs hello, that's this line right here. All needs hello. Then we say hello needs hello.o and emitter.o, which won't fit daggone it. Everybody's got to have a size 50,000 font. Give me a minute. Okay, that's these two lines. Hello depends on these two children. Hello depends on hello.o and emitter. Okay, what does hello.o need? Hello.o needs two children. Hello.c and emitter.h. Hello.c and emitter.h. What does emitter.o need? Emitter.o needs two children. It needs emitter.c and emitter.h. And so, now we see this graph is the same as this, if we know the rules. When we have a colon, that tells me, hey, I'm going to have a list of children nodes, child nodes. And there it is. if you look at the makefile on page 2, you should see this structure. Okay? There's more stuff in there, but this is the structure, basically. Now we're going to add to it. All hello doesn't really do anything, it just gives us a special target. So that's phony. Phony targets are targets that don't make a file. All does not make a file. All just says go build hello. So it's phony. Okay. Hello. Hey, hello is a link. Right? Hello.o, emitter.o is going to make hello. That's a link. We know how to link from page 1. Page 1 we have a link. How do we link? Pretty easy. GCC, hello.o, emitter.o, minus o, hello. That's the rule. This says if these change, if these are newer than this, or this is missing, do this. That's how it works. If this file is newer than this file, or this file is newer than this file, or this file is missing, then do this stuff. Same thing here. How do we do this one? This is a compile. How do we compile? We're going to GCC, wall, extra, pedantic, standard equals C99, true long. Let's go again. What else we got to put in there? Then finally, the good stuff. Hello.c, minus o, hello. But we forgot something. What did we forget? Compile only. Minus c. Compile says don't link. Whew. All right, we got it. It's hard work, but we did it. Same thing here. Hey. You didn't let me put the .o there, Abby. And now it's finished. Now, this makefile has all the build rules. It's pretty good. The problem is I've got it in Notepad and I need it in Unix. But you can see now, these lines show you the graph. That builds the graph. And this is a special thing to tell you all doesn't really have any rules. Now these lines, what is this? This is the link. This is the build. This is the build. Now, let's go back to dev D and let's put it in. So I'm going to do that makefile again. What did I have? All. And then you have to press the tab key. Okay? Tab. Has to be tab. Then depends on hello. After the colon, you have to have tabs. Before each rule, you need a tab. There's no rule. So go to the next one. Hello, colon, tab, hello.o, emitter.o. Enter. We're going to put in the graph and then we'll put in the build rules. So, what does hello.o need? Tab, hello.c, emitter.h. I forgot the C here. Sorry about that. Then, no, that's O. Hello.o. Then emitter.o needs emitter.c and emitter.h. And finally we have to tell him, hey, all is not a real target. Now I have the graph. Save it. Just in case, right? Anytime you want to save, just colon W. It'll save. Now we can go back and we can add the rules. The first rule here was the link. So, tab, GCC, hello.o, emitter.o, minus o, hello. You need one blank line in between each set. Okay, what do we need here? This is not a link, this is a compile. So GCC, Wow, extra pedantic. Whoa. That's my warning and my say C99, not C89. Okay? Then tab, no tab. Then we need some more stuff. We need our optimization and our build target. Finally, we need to say compile only, hello.c, output, hello.o. And see, the output has to match this node. Just like the output of this one has to match this node. Okay, looks pretty good. I'm so glad I'm in VI. Right? Boom, much easier. Tab. Okay, it's looking pretty good. Save it. Run it. Whoa! Magic! Oh, magic. Now, remove the .o and the hello again. Make. Wow, 4 letters. M-A-K-E, enter. Much easier. You have to type it one time in the make file, but then it's easy. But, you see this? I don't want to type this every time. I told you, John is lazy. We're going to put in a clean and a disclean. Clean should remove .o and core. Disclean actually removes your main program. In our case, hello. So, let's edit the make file.
ใช่ติดตรงนี้เลย
Clean depends on nothing. It's another graph. Okay? This file has more than one graph. Clean doesn't depend on anything. It's a leaf node. Okay? Clean is going to say, basically, that stuff. Disclean. Disclean says, depends on clean. First, do the clean, then remove the main application. And clean, oops, sorry. Clean and disclean are not real targets. They're phony. They don't make a file. There's no file clean. There's no file disclean. Any node that does not equal a file name must be in the phony list. Okay? Now, I'm going to show you the tabs. It's a little hard to see on the projector, but you see this blue control I? That's a tab. So you can see, I got to have tabs here. I got to have one tab here. Here, tab, and then space, space, space after that. But the tab is the divider between colon and the dependency list. And tab is also used in front of all the rules. Okay, I'm going to set it back to normal. No list. Let's try that. Make clean. Make disclean. Disclean does clean, and then that. And now, hgstat, he says, I don't want to make a file. Let's do a build. Looking good. Let's make some change and see how smart the system is. I'm going to show you why you love Nate at night. When you dream, you're going to dream about how much you love Nate. You're going to say, I'm sorry, dear. I have to drop you. Yeah, I'm going out with Nate now. Nate is fabulous. We're going to change hello.c, and we're going to change our message. And we're going to say, good evening, world. I changed one file, right? What does make do? Make knows what to do. Make says hello.c is new. Newer than hello.o. Make hello.o. Now check. Hey, hello.o is newer than hello. Relink. He did not compile emitter. Emitter doesn't need it. Make does it all based on the time of your files. Okay? These times right here. It's critical. Now, let's take a look at my make file and let's look at the one on your paper. You see the one on your paper is nice. It doesn't have this. right? Look at your paper, page 2. Your make file is nicer because we use variable. This make file, no variables. Right? I said keep it simple the first time. Let's make it better. Let's use some variables. So, we're going to use some variables. First, we'll say CC is GCC. And now, everywhere we had GCC, we're going to use the variable. Doesn't look like a big change yet, but it's a big one. The next thing we should do is set what are the warn flags. Now, everywhere we had that, we can just say warn flags. Okay, that's better. Now, let's do the optimization. Now we can put opt. Now these lines are not so long, right? I can join it. It's not so bad anymore. I can join it. Does it still work? Let's test. First, make it this clean. Make. Yeah, it's the same. Okay? It's still working. And that's good because look, if I want to change it to 03, I change it in one place. I don't change it in 2 places. If I had 10 modules, the old way, I make 10 changes. Here, I make 1 change at the top, and then everybody gets that change. I can change my march. You know, if you're on a 386, or you're on a Spark chip, or maybe MIPS, you know, you might have MIPS. You can change your machine type for the MIPS computer. Okay, let's change this back to 02. I like it, but it's still not perfect. It's good, but it's not perfect. Why is it not perfect? Well, really, 02 is the optimization. This stuff is about my machine. So I'm going to split that out and make C flags. And that's going to have warn flags, optimization, and that stuff. That's going to make C flags. And then, look at this, I can make this even easier. Now I've got C flags. It's looking pretty good. Let's try that. After you modify the make file, you probably need to make this clean anytime you modify the make file. Because when you change the make file, you change the graph, and you might change the graph. If you change the graph, the old dependency rules are no good. You don't know, you got to restart. So if you change the make file, make this clean, and then make. Still working great. And look at that make file. So much nicer now. All this stuff is in one place only, at the top, and it's easy to understand. Optimization, 02, 00, whatever you want. Warning flags. You know, you want to compile the old C programs? You can do that. C89. And you can get ANSI 1.0 C if you want. So that's cool. If you have a specific thing here, you know, 4-2 duo, you can put that for your machine. It's not portable, but it'll be a little bit faster. Okay? So, I'm loving it. There's only one problem. There's no C flags here, right? But sometimes I need a flag for my link. So I'm going to add something called LD flags. LD flags is like C flags, but it's for linking. And by default, we just don't have any. but it's there if we need it. Wow, that is so beautiful. Is that exactly the same as the file in my document? I think so. Yeah, that's it. So now I've shown you step by step. You start with the picture. Draw the picture on paper somewhere of your dependency tree. Then you make the graph and you put in the commands, maybe by hand. But the important part is this structure. Right? Then you convert the picture to this graph, and then you type this in Linux, like this, step by step. Make files are not hard, but it's step by step. Now, we've used 1 hour, so let's take a break. Okay, let's take a break for 5 minutes. 5 minutes, 18:05, come back. Okay? Amity, if you need to use the bathroom or something, get a drink, now's the time. I'm gonna go upstairs and get my soda, and I'll be back. Oh, I'm on TV. I'll be back.
แล้วเมคไฟล์เสร็จแล้วทำไงต่อไม่ต้องเบคธรรมดาใครทันก็คันเทพอ่ะ
รู้แค่ว่าพิมพ์เมนไฟล์เสร็จต้องสร้างออบเจกต์ไม่ทันเลย
เจนยังฟังไม่ทันเลยว่าเราจะฟังทันกันเนี่ย
สร้างเป็นออบเจกต์ไม่ได้สร้างอะไรเงี้ยก็ไม่มีสร้างเป็นโอด้วยอะไรอย่างเงี้ยกูยังไม่เสร็จเลยกูจริงๆกูสร้างแค่เมนไฟล์กูพอไม่ใช่ตรงนี้แล้วมันจะกูพอ ที่นี่มีไฟล์สโคดซีเกียเลยไอ้บอมมึงมี.o เลยเต็มไปหมดแล้วนะ
เมคไฟล์เสร็จแล้วครับเมคแล้วมันก็จะปรับไฟล์ไปหมดเลย
ลอง
ดูแล้วนั่นแหละ
เฮียหล่ออ่ะติ๊กจูบีกัน
เมคก็
เฮียทำแมวอะไรไม่ได้เอาเฮียหายไปตัวเดียวนะครับโลโก้หายไปตัวเดียวไม่หายไป2 ตัว
เฮ้ยทำถึงไหน
ทำยังไงไม่รู้แต่รูปตามไม่เห็นที่ไหนบ้าง
โอ้ยมีเยอะเนาะ
ของไหนอะ
ยิ่งเป็นสปีกเกอร์แบบ
บ้านมันจะเป็นกล่องไอคอน
มอง
เปิดไม่กันแนว
ไอ้พวกจิ๊กคิวแบบเกมนี้
จริงหมดเรื่องแต่ดูไฟล์
กล่องไหนไอช็อปเปอร์
คนลิงเหรอของอะไรอ่ะ
Okay, let's go for part 2. Part 1 was makefile. You now have a makefile. You have step-by-step instructions how to do it. You should use that makefile as a template for your projects. Let me get logged back into Deck and we'll get started. Yeah. Yo, $10. Oh yeah, if I get $10 from everybody every time, I'll be. Okay. I'm working on it. Okay. I'm right in, so you go home. Go to the days. We'll make this clean. I got a problem. My make file is not checked in. My hello.c has some modified. Let's check in the make file first. So let's HG add the make file. I'm going to show you how to check in just one file. I don't want to change to hello.c. I don't like it. But I want to change to the make file. See? If you put the file name, he only checks in that file, or whatever file you say. Normally, he checks in everything, and that's what you want most days. But sometimes you want to check in just 1 or 2 files change. And you can do that. Just put them right here. Now, let's do our HG update -c. HG stat. We still have the make file, but we did not change hello.c. Beautiful. That's how you use HG update C. Right? That says clear out any modified files, put it back to normal. But we wanted to keep the make file. So we couldn't clear here because we killed the make file. So we commit the make file if you like, and then we clear, and that fixes hello.c back to normal. And we will make hello. There you go. Wonderful. Now, let's go down to, let's go to page 3. Page 3. If you're from the UK, you're going to laugh about the idea of page 3. Because in the newspaper in the UK, page 3 has the calendar girl. But for us, page 3 has GDB. The first thing we have to do is break our program. Because our program is good. If I want to show you the error, we have to break the program. A simple change, okay? You're going to modify emitter.c, and you're going to put in this little change here. They tell you that 9s are lucky. Subtract that. Crazy! You know it's going to die. But you can type it by accident if you're tired. I needed a program that's going to die. So make... he only changed to minute.o. Really? Let's run it. Yeah! Sigfall, my favorite. Now, how do we fix it? We need a core dump. Right now, I've got no core dumping. I gotta turn it on. Okay, now, this says turn on core dumps. It's on your paper. Now, the next thing we have to do is build for debugging. Our first build is no debug. We gotta rebuild. Debug, no optimizer. Debug link. Oh no, Mr. Bill. Oh no. What happened? I forgot the equal. Okay, my fault. Let's try it again. Equal. Equal. Whoa, minus G. Oh, there we go. Fine. I forgot the equal sign the first time, which was stupid. Yeah, no equal. Now, after you do that, you see the minus G, right? Minus G, minus G, minus G. And your optimize is off. Don't optimize, don't optimize. Now, run it. Segmentation fault, core dump. We want that. Core dump is good because we're going to debug. You only get that if you turn on core dumps. Now, what have I got? Core, right here. What happens if you VI that? Don't VI it. I'm just going to show you. Bad things happen. Okay? Okay. That'll tear up your terminal. You know core is special. Now, follow along on your sheet on page 3. They have instructions. Here we go. I'm typing in the same thing. GDB minus G LO core. Hi, core. How are you? Oh, that's bad. Minus Q. Minus Q. Okay, the papers Q like this line. These are new this year. Okay, there we go. It says you have signal 11 segmentation fault. Now, where it really happened was in some sprinkling function. We don't even call sprinkling. You need to get a backtrace. BT. This shows you the stack. Now take a look. Do I know that function? No, that's not in my program. Did I call this function? No. Did I call this function? Yeah, I wrote this function. So I want number 2, frame 2. So I ask for frame number 2. Frame 2. No, frame 2. Okay. He tells me the line, the crack. This is the bad line. But I don't know why. Let's print. Print MSG. Monosodium glutamate. MSG is good string. Hello world. Print the expression. Yeah, GDB can do math. Aha! Aha! Out of bounds. MSG is okay. But MSG minus 999